So welcome everyone to the third demo. In this one, I will show you how to aggregate cells from Stardist, CellPose, instance egg, or general QPath, and how to import them into HiVis. So previously, I showed you how to work with HiVis and how to import annotations and classifiers. Now there, I showed you how to import annotations, which is very similar to single cells. Actually, if you use the QPath single cells as segmentation, those are exported as GeoJSON, so this is just like annotations. But in this case, I will show you how to do it from the Groovy scripts that we provide for the CellPose and Stardist. So as before, we load the data that we saved before. And then we will use for this tutorial only a subset. So 400 by 400 microns, just to speed things up and make it easier. But of course, you can do it on your whole data. I do say that on the whole data, it might take some time. So importing, for example, 50,000 cells can take few minutes. So don't worry if it takes some time. You will also have like a bar that tells you how long they are being imported. But in this case, we will have this subset. So now we can export the images. And in the output folder of the subset, we will have the full resolution image, GeoJSON, and the CSV, which we can use in the QPath Groovy script. For example, the Stardist or CellPose. So now we use the Groovy scripts, which I will not cover here. And this will output two files. One is this detections.csv file. This will have all the information about the cells and the different bins. So we can read it with pandas. So we will have data frame. And also we will have a GeoJSON path. So those are the cells in GeoJSON. So those are the actual masks that we can import. This is not necessary. You can skip this. But it is very nice for plotting, which I will show you later. So now all we do is aggregate cells. We specify this table that we imported here. We give it a name. So our subset object will have under it this single cell layer. Now we specify which observations from QPath we want actually to add here. So QPath give you like 10 or tens of different measurements. For example, the area, the length, the intensity of colors, and so on. So we can actually get those into our data, but again, you can skip this. We can also take metadata from the bins themselves. So in the sub, I remind you that we have from previous tutorial, we have a classifier of where are we in the intestine, and also are we in a muscle, or are we in a villi, or in the lumen. So we can actually aggregate those based on the mean or the mode in this case, because those are strings. So each cell now will have different classes. And lastly, we can specify the GeoJSON path. We can actually skip this and later use it to import it using different function. So let's run this. And as you can see, it takes some time. Again, here I only have like 3,000 cells, not like 50,000, which you will have in one slide. Yeah, so I have 7,000 cells. So, okay, now I have this. So now I can import the GeoJSON. As I said, we don't need it because we used it here, but we can also import it using the import geometry function. Now, now if we look at the subset, it will actually have this aggregations dictionary. So we can access the single cell aggregation, which we just created here. We can access it with this term. So this will have those different functions, for example, this import geometry and plotting function, analysis, and so on. So now we have this object of single cell. It has a name, it has a shape, and so on. So this is just the name. We can rename it, of course, and so on. And this object is actually connected to our parent object, which is the subset in this case. So if we call this .viz, it will get back to the sub. Okay, so now if we look at the sub, so I already ran it, but here if we call just to sub the sub to print it, you see that we have our object with 30,000 bins with different obs and vars, but we now also have one aggregation. So this is one layer on top of the bins. In this case, this is the single cell. We can have multiple, I will show you later. And now we can, for example, plot them. So now we will call this object with plotting functions, such as spatial, cells, and so on. And we have here the different dots. Those are the single cells. And we see that, and here, those are the masks. And we see that those got the classifier name from the bins. So we had the bins, we aggregated, so all the bins here were muscle, so the cell here also received a muscle. And we can also plot genes and so on. So now we have this object with undata inside, which has the expression levels of all the genes and so on, which we can work on. So now what you can do with it, you can do plotting, of course, you can do different analysis. For example, with ScanPy and SquidPy. So now I will show you just a basic pipeline with ScanPy. Because I will do Leiden clustering, I want to install it first, but you don't have to. And then I do normal single cell analysis. I take the undata from our object and we copy it. I think you can also do it directly on this undata, but then you might break it. So I wouldn't do it. I would do it like this. So you copy it, you work on this, you do whatever you like. For example, I normalize, I log transform, I find highly variable genes. Um, um, I scale it, I do PCA, I find neighbors, UMAP, and Leiden. So now if I plot it, I will have this undata with Leiden clustering and UMAP. Now to get this back into our object, all we do is we take our object dot merge and we specify the undata and we specify what we want to merge. In this case, we want to merge the Leiden. It will also merge the UMAP and so on, but never mind. So now if we look, we will have this Leiden column inside our object, which are the Leiden clusters. Now, optionally, we can reorder them to be categorical or whatever order you want and so on. This is optional, it's just for plotting. And if we look, we have this now, each cell has one cluster. Now we can plot them. So we do a spatial, we see all the different clusters. So this fifth cluster is the muscle, for example. Those are the epithelial, the zero cluster, and so on. We have also a plot of UMAP. So yes. And we have a histogram of all the clusters. And we have this beautiful plot of the masks themselves. This is only possible if we imported the GeoJSON. Again, all the plotting stuff will be covered in a different tutorial. So now we have those cells. Now we can actually transfer information back into the bins. And we are doing it simply with using the sync method. So we call our object.sync and we tell it what to sync. And if we look at our subset object, columns, we see that now we have this laden added. So each 2 by 2 micron bin now has a laden class. As I showed you in HiVis object, we can access it with just calling something inside the object. So it's very simple. In this case, we take the cluster 0 mask, and then we can take our object and we can subset it. Same as the HiVis object, you first specify the columns, the observation, sorry, and then you specify the genes, the vars. In this case, we will have this cluster 0 aggregation object, which will have only the class 0 and the laden 0. We can rename it, and lastly we can of course copy it. Now if we look at the subset object, we have all of those vars, ops, and so on, but we now have different aggregations. So we have the single cells we imported, we have the cluster 0 which we created here. This is only the cluster 0 cells, and here we have a copy which of course we can modify and so on. Same as before, we save our object, so later we can use all of this data.